Angles and angle measures. Okay, we're going to start off by talking about angles and standard position. So if we need to draw an angle, we can kind of make an XY coordinate like you see on the right, and then we're going to draw our angle opening up. So something to note is that 0 is always right here, so you always start your angle along this line, and then you open up approximately whatever the degree is. So a few things to note is that every quadrant is 90 degrees. So this is 90 degrees. That's another 90, so there's 180. Another 90, that makes 270. And then another 90, you'd be back to where you started at 360. We have what's called an initial side and a terminal side. So your initial side is the side that you start on, that I've already darkened with black. And the terminal side is right here where you end. Okay, so if I'm going to draw these, start with my XY axis, and I'm always starting right here. So here's my initial side along the positive x-axis, and I'm just going to start drawing my curve. So that's 90 degrees. Another 90 is 80 degrees. And then we're going 240, so it's going to be about right there. 270 is where the negative part of your y axis is. So about 240 is right here. It will not be exact. Okay, if you notice, this next angle is going to be greater than 360. So we're actually going to go around more than one time. So if I go around one complete revolution, that is 360 degrees. Then I can add on 90 more, and I get to 350. I'm sorry, I was just interrupting that problem, so let me restart it because I'm not sure where I left off. Okay, so XY axis, start on your initial, and then go around, that's 360. If I go another 90 degrees, I'm up to 450 degrees, and I need to go 50 more, so it's going to be about just a little bit over half of the way. So about right there, there is the 500 degree mark. Okay, and this last one, a negative degree. Instead of starting at your initial side and going up and over, we are going to start at the initial side and go down. Remember, halfway between my two coordinate axes is going to be about 45 degrees. So I went a little bit further than half, and that's negative 50 degrees. Okay, so finding coterminal angles. If you noticed that 500 and 140 are coterminal angles because they're both going to end at the same place. So we're going to find one positive and one negative angles with negative 45 degrees and 395. So let's start with negative 45 degrees. Okay, so if I were to graph that, that would be right there. We go negative. So a coterminal angle with negative 45 degrees is just going to be another angle that ends at the same place. So I'm going to draw another one. This time I'm going to go positive. The angle that ends right here would be 90 degrees plus 90 plus 90 plus 45. So that angle measure is going to be 315 degrees. So 315 and 45 are coterminal. And now we're going to find a negative that's the same as well. So let me switch to yellow. So if we're going to go negative, we need to start by going down. And then go all the way back till we hit this again. So we've hit it again. And this time, our degree, we have gone 90 plus 90 plus 90 plus 90. So we've gone a whole 360 plus 45 more. So that gives us 405 degrees. So these are all negative 405 degrees. These are all coterminal because they end at the same place. Okay, so now we're going to do this again with my 395. Okay, so my original angle 395 is going to be a whole 360 around plus 35 more. So here's 395. If I make another positive angle, start at my initial side, I'm just going to go up. That is just a 35 degree angle right there. So 35 and 395 are coterminal. And then if I do a negative angle, so start at my initial spot and go backwards, that is going to be 90 plus 90 plus 90 plus, I have 35 less than 90 here, so it's going to be 55. And that angle is at 325. Okay, so now instead of having to draw these every single time, we can kind of just look at the rule going on here. If you take the angle that you're starting with, 395, you can add and subtract 360 from it, or you can add and subtract 360 from it, 360, to get each terminal angle. So I'm going to subtract 360. I get 35 degrees, so that's where that came in. And then if I subtract 360 twice, I'll get my negative angle of negative 325. I forgot to put the negative on there. Sorry. So by just adding or subtracting 360 over and over, you can get all the terminal angles. I could have also added 360 to my 395, and I would have gotten another coterminal angle. Okay, next, instead of degrees, we're going to start looking at radians. So a radian, you don't need to memorize this, but a radian is just the distance around the circle that is equivalent to your radius. So this arc length right here is the same length as my radius. So you will need to copy down this unit circle, and it will be a good thing to memorize if you would like to do that. Okay, so converting between degrees and radians. These are my two conversions. You'll want to write these down and make sure you know which one converts you from what to what. So this first problem, A, I'm converting 120 degrees into radians. So whenever I go from degrees to radians, I want to use the formula on the left, the pi over 180. So I'm going to take 120, and I'm going to multiply it by pi over 180. In your calculator, you can simply put 120 divided by 180, and you get 2/3, but the pi needs to go on top. So don't actually evaluate pi, leave it as the symbol pi. For B, I have negative pi over 12, and I'm going to multiply this by 180 over pi. So the way I remember which formula to use is if there is already a pi, I want to cancel the pi's out, so I put pi on the bottom. If there's not a pi, I want a pi left in it, so I put pi on the top. Okay, and now I'm just going to do in my calculator 180 divided by negative 12, and I get negative 15 degrees. The pi's cancel out, so there's no need to put pi. Okay, pause your video and do these 4 problems and then restart it to see the answers. Okay, so you can check my answers on this. The last one was a little bit tricky, but since it gave me a decimal, I'm going to keep my answer as a decimal as well, as opposed to making it a fraction. I picked 2 decimal places because that's what it started with the 0.28. Okay, next thing you need to have down is the arc length and area formulas. So in this case, arc length is denoted by an S, and that's just going to be the length of the arc. R is your radius, and theta is the angle right here. Okay, we have a picture of an outfield and the measurements of the side. So 200 feet and our angle is 90 degrees. So we're going to find the length of the outfield fence, so the distance of the arc, as well as the area of the field. So let's start with our arc length. S equals, our equation is r times theta. R here is 200 because that's the radius of our circle, and theta is 90 because it's a 90-degree angle. So our arc length is 18,000 feet. Make sure you put your units on here. Area formula was 1/2 times radius squared times theta. Here our radius is 200 and our theta is still 90. Plug that all into your calculator and you get this answer, feet squared.